Hi there, scientists. It's PS Science here, and today we're going to talk about energy and roller coasters. That's right, roller coasters. Are you ready to ride? Okay, first of all, roller coasters are so exciting that even waiting in line for one gets me all excited, right? Thinking about going up and down those hills and zooming around, but when I am waiting in line and thinking about it, sometimes I feel like I almost can't get on. And the worst part for me, and the best part at the same time, is when you do the slow tick, 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 up the hill before you go down the first hill. The anticipation, scary, right? And if you like roller coasters, would you rather be in line on a kiddie coaster or one of the big giant loop coasters? Think about that. Now imagine yourself on the ride. Make sure you've got your seatbelt on, okay? And close your eyes and imagine what it's like to zoom around that track, up and down the hills, maybe through some loops. What makes a roller coaster so exciting? That's what we're going to begin to investigate today. And you are going to begin to design and build your very own roller coaster. Now, unless you have a shrinky-dink machine, you won't be able to ride your roller coaster because you need to be really small. But you can pretend that you are the marble or the car or whatever you use to go on your track. Now, I don't know about you, but it would be hard for me to think or talk about roller coasters without thinking about energy. Let's start with the investigation of ramps and keep in mind energy. What do roller coasters have to do with energy? What is energy? How many different kinds of energy can you think of? Why don't you pause for a second and write some of those down in your science notebook? How many kinds of energy can you think of? And what are they used for? So in my hand here I have two marbles. I've got one small silver metal one, and I've got a larger white plastic marble. The metal one weighs more than the white plastic one, and I've set up a basic ramp using a ruler that has a groove in it. That's going to work as my track. And I've set it up on one book, not too thick, it's about 1.5 inches thick, and I'm going to send the marbles down the ramp, different sizes, different weights, and we're going to see what happens when they run into an index card. Let me show you how I'm going to set up the index card. So check this out. I don't actually have an index card the size that I want, so I'm just going to use a greeting card, and I'm going to set it up at the end of the ramp, just like this. So you can use any card that's a little bit thicker, like an index card, a greeting card, construction paper. Don't worry about it as long as it's sturdy enough to stand up like a tent. Here's a helpful tip. Anytime you're using marbles and you don't want to lose your marbles, I find it's very handy to have a roll of tape like this because you can put them in the center and they won't roll off the table 300 times. Very efficient. Handy scientist tip. And that's kind of fun all on its own. It's a marble race. So I just want you to notice how high the ramp is to start on the one book. Okay, so I'm going to start with the white marble. It's plastic. It's lighter than the metal one. I know you can't feel that, but I'm telling you the truth. I'm going to start it here, and off we go. Okay, that was the white plastic marble. Let's try it with the small metal marble, much heavier. Move the card back. Ready? Here's the plastic. Ooh, that was a good trial. Here's the metal. This time I'm adding some books because I don't really have any thick books. By the way, you should read these books. Amazing. Miraculous Journey of Edward Tulane. Bud Not Buddy, two of my favorites. I'm gonna set up my ramp again. Let's move that over. Set it up here so you can see it's a little bit higher. The slope is definitely a little bit higher. I'm going to push my card to the end, and let's try it again. Going again with the white. Okay. Metal. So what did you think with those ramps, scientists? What would happen if you kept adding books and increased the slope? That means you're going to make the hill higher, right? Think about that in terms of energy. Think about that in terms of your roller coaster to design. Remember, your challenge is to get that one full loop or an up and down hill. So what does energy have to do with it? Now remember, there's more than one kind of energy, but we're focusing on energy in terms of your roller coaster designs and how you will use energy to meet the challenge of getting your coaster through one complete loop or up and down one hill. Good luck, scientists. See you again soon. I'm going to get to work on my shrinky-dink machine so that I can ride some of these roller coasters you build. Okay, scientists, thanks for watching. Did you enjoy that lesson? Subscribe below to see more fun science videos. You can also become a member of PS Science on Patreon to support what we're doing. See you next time.